Now, another thing that people often say is that for guessing, two identical theories, suppose you have two theories, A and B, which look completely different psychologically, have different ideas in them and so on, but that all the consequences that are computed, are exactly the same. Maybe say they even agree with experiments. The point is, though, that the two theories, although they sound different at the beginning, have all consequences the same. It's easy usually to prove that mathematically by doing a little mathematics ahead of time to show that the logic from this one and this one will always give corresponding consequences. Suppose we have two such theories, how are we going to decide which one is right? No way, not by science, because they both agree with experiment to the same extent. There's no way to distinguish one from the other. So the two theories, although they may have deeply different ideas behind them, may be mathematically identical, and usually people say then in science one doesn't know how to distinguish them, and that's right. However, for psychological reasons, in order to guess new theories, these two things are very far from equivalent, because one gives a man different ideas than the other. By putting the theory in a certain kind of framework, you get an idea what to change, which would be something, for instance, in theory A that talks about something that you say, I'll change that idea in here. But to find out what the corresponding thing is you're going to change in here may be very complicated. It may not be a simple idea. In other words, a simple change here makes maybe a very different theory than a simple change there. In other words, although they're identical before they're changed, there are certain ways of changing one which look natural, which don't look natural in the other. And therefore, psychologically, we must keep all the theories in our head. And every theoretical physicist that's any good knows 6 or 7 different theoretical representations for exactly the same physics, and knows that they're all equivalent, and that nobody is ever going to be able to decide which one is right at that level, but he keeps them in his head hoping that they'll give him different ideas for guessing. Incidentally, that reminds me of another thing, and that is that the philosophy or the ideas around the theory, a lot of ideas, you say, I believe there is a space-time or something like that in order to discuss your analysis, that these ideas change enormously when there are very tiny changes in the theory. In other words, for instance, Newton's ideas about space and time agreed with experiment very well. But in order to get the correct motion of the orbit of Mercury, which was a tiny, tiny difference, the difference in the character of the theory with which you started was enormous. Reason is, these are so simple and so perfect. They produce definite results. In order to get something to produce a little different result, it has to be completely different. You can't make imperfections on a perfect thing. You have to have another perfect thing. So the philosophical ideas between Newton's theory of gravitation and Einstein's theory of gravitation are enormous. The differences, rather, are enormous. What are these philosophies? These philosophies are really tricky ways to compute consequences quickly. A philosophy, which is sometimes called an understanding of the law, is simply a way that a person holds the laws in his mind so as to guess quickly at consequences. Some people have said, and it's true, for instance, in the case of Maxwell's equations and other equations, never mind the philosophy, never mind anything of this kind, just guess the equations. The problem is only to compute their answers so that they agree with experiment, and is not necessary to have a philosophy or argue or words about the equation. That's true in a sense, yes and no. It's good in the sense you may be, if you only guess the equation, you're not prejudicing yourself and you'll guess better. On the other hand, maybe the philosophy helps you to guess. It's very hard to say. For those people who insist, however, that the only thing that's important is that the theory agrees with experiment, I would like to make an imaginary discussion between a Mayan astronomer and his student. The Mayans were able to calculate with great precision the predictions, for example, for eclipses and the position of the moon in the sky, the position of Venus, and so on. However, it was all done by arithmetic. You count a certain numbers, you subtract some numbers, and so on. There was no discussion of what the moon was. There wasn't even a discussion of the idea that it went around. There was only calculate the time when there would be an eclipse or the time when it would rise, the full moon, and when it would rise, half moon, and so on. Just calculating only. Suppose that a young man went to the astronomer and said, I have an idea. Maybe those things are going around, and there are balls of rocks out, like rocks out there. We could calculate how they move in a completely different way than just calculate what time they appear in the sky and so on. So of course, the Mayan astronomer would say, yes. How accurate can you predict eclipses? He said, I haven't developed the thing very far. He says, but we can calculate eclipses more accurately than you can with your model, and so you must not pay any attention to this because the mathematical scheme is better. And there's a very strong tendency of people to say against some idea, if someone comes up with an idea and says, let's suppose the world is this way, and you say to him, well, what would you get for the answer for such and such a problem? And he says, I haven't developed it far enough. And you say, well, we have already developed it much further, and we can get the answers very accurately. So it is a problem as to whether or not to worry about philosophies behind ideas.